Welcome. Um, I don't know how to start these videos, so that's how I start, I guess. In this video, I will show you the two contracts that I use for PAY.GAME. If you're new to Solidity or you have gotten no experience yet whatsoever, I think this might be interesting to you. If you're very experienced, then this is probably too basic, but maybe you will enjoy it. Maybe you got some feedback from me. So if you go to the website, there's, I guess, two things that kind of happen. So first, when you first visit the website, it will show you the leaderboard. So those are all the players' names with the links and their scores. So this data is retrieved directly from the blockchain. There's no like Postgres database or anything else behind this. It gets directly taken from the contract, which is kind of fun because anyone could create their own front end because the database is public. So I'll show you how that works kind of. And when you enter a score, when you participate in the game, it's kind of similar, like it sends a transaction directly to the blockchain, to the contract. And it gets kind of sent to everyone that's looking on the website right then and there. Okay, so let's go to the contracts. By the way, the links for the contracts are on Twitter. Probably also in the tweet where I linked this video, but yeah, you can probably find it somehow. So there's the game contract and the prize contract. So because if you participate in the game, you will get an NFT, which I call the prize, which is this coin. And then if you got first, second, or third place, you also get a special trophy NFT, but you will lose it if someone else gets that spot instead, which is kind of like a nice mechanic that I haven't seen before, where you can actually lose an NFT without your permission to transfer it, basically. And then if you lose the first place, it's kind of sad, so you get like a consolidation prize, which is this one. And that's all managed through the price contract, which is like an NFT contract. Let's first go to the game contract though. So I guess the most important function is, let's just scroll to the top. So this is the contract. There's a few files in here. We're just gonna look at the game.sol file because that's kind of like my code and everything else is kind of like boilerplate. So it's called game. There's some variables here. It's not super important. There's a struct, which is kind of like a concept, like an object of player. Each player has a name, a URL, a timestamp with the last payment, a score, which is the current score, and a boolean that kind of stores whether they received this NFT that I mentioned, because we only send it once to each user. And then we keep track of the top 3 high scores. We don't keep track of all the high scores because we keep track of the players, and each player has a score, so we can kind of calculate the leaderboard and rank it when we need it. But we don't actually need to store that ranking in the contract because that would take up extra gas, which is costly. But we do need to keep track of who is on third, second, and first place, so we know how to transfer the NFTs around. So that's what this high score is, with only 3 entries, the top 3. Then there's some more variables that keep track of all the players and their wallet addresses and that kind of stuff. There's an event called new payment, which gets emitted when there's a new payment, which is nice. I probably cannot show you it unless someone pays right now, but if you're on a website and someone pays, it will show you in real time, actually. You will see coins dropping and there's a sound effect and the player's name will start flashing, so it's very clear that someone just paid. And that's all kind of real time. There's some delay in it maybe, but that's what the event does. But yeah, this is the most important method or function called pay, which is called if you enter a score here. And so it takes 2 parameters, name and URL, which is this right here. And then the score, it's maybe it's not complicated, but it gets sent in a different way. Like whenever you send money to a contract, whenever you send ETH to a contract, you it sends. It's not a parameter, but it's called the message value, which we will use further down in the code. But first we check if the request is even valid. So for example, the name cannot be blank. The name cannot contain any special characters like emoji and that kind of stuff. The name cannot be longer than 32 characters. And the same for the URL, it cannot be too long. Then we check, we get the players array and we use the message sender, which is the wallet address of the wallet initiating this transaction. So we get the player object or struct for this wallet, and if there is none, it will automatically be created. That's kind of how Solidity handles that. This is not important. Then we check, is the player score 0, which means we're a new player. So we're adding the player to the list of addresses. It's just a way to keep track of which players are already playing and which are new players. Then we mint on the price contract a participant NFT, which is this coin. Then we set the name of the player to the name that was provided, and we set the URL to the URL that was provided. If the score was not 0, which means the player played before, so it's actually possible to add additional money to your score or change your name or URL when you're already in there. Like it won't create a new score, it will just update your existing score, and it will add the money on top of the money you already had. So if that's the case, then we will set the name if it was different before, and same for the URL. And finally, we create the payment, which is down here somewhere. We check that it's above the minimum amount of 1 Ether. Again, we get the player, current player. We increase the score with the message value, which I just mentioned. We set the last payment date to right now, and that's because if there are multiple players with the same score, we still want to have a, what do you call it, like deterministic way of ordering them, because if we just order by score, it's not clear which one should come first, and I want it to always be the same ranking. And so I did it based on last payment. So whoever has this score first has the highest ranking for that score. So I was the first one to pay 0.01 ETH. So maybe it's not fair in hindsight, but I will always be the top player for this particular score. I thought it was fair that whoever gets a certain score first kind of ranks the highest for that. But in hindsight, maybe I should have reversed it, or maybe I shouldn't have paid 0.01. But yeah, I cannot change it anymore because that's the way the blockchain works. Maybe I can actually update my score to 0.02, and then I will not be the first one for this score. I'll look into that later. Anyway, back to the code. Okay, so we got the new score. We calculated, okay, what's the new score for this player? Which we don't use immediately. Then we send the event that I mentioned. And then we check, so there's some logic. I'm not gonna go through all of it. But we're gonna check if we need to send NFTs, like the 3 trophies for the first, second, and third place. So we wanna do as little logic as possible because it costs money to run this logic. It costs money for whoever initiates the transaction, so that's the player. So first we check, is this new score, this new player or this existing player, is this score less than third place? And if so, we don't need to do any calculations because they're not gonna get an NFT for the first 3 spots. So we return early, and that's the fastest way through this method. But if it's not less than third place, then it means there are either going to be first place, second place, or third place, and we need to shift those NFTs around. If we get a new first place player, then the current first place player will get the second place NFT, and the second player gets the third place NFT. So there's a lot of like moving around of NFTs, which is quite costly in terms of gas, but that's the way it works right now. And that's kind of what's happening here. You can go through here if you want. And then there's one interesting thing maybe that if the first player loses their spot, and it's the first time they lose the first place spot, they will get the Hall of Fame NFT, which is this one. I once won PAY.GAME, but now all I got is this lousy NFT. So there's only a few people that will have this, basically anyone that has ever been on the first place. So yeah, there's logic, a lot of logic right here. And it's written in a way where it only runs the code if it absolutely needs to do it, because again, it costs money to run this code. Then there's some functions here that's not super important. Yeah, that's basically it. Yeah, and so yeah, within this code of this high score reordering, that's where all the minting and the transferring happens for the NFTs. Yeah, then there's some other methods like withdrawal, which allows me as the owner to withdraw all the ETH that's in this contract's wallet, so it gets into my wallet basically. Hopefully I'm the only one that can execute that. That's what this only owner is for, but who knows. Then there's a method to get all the players, which is used in the on the website. Lifetime balance, so that calculates all the money that was ever spent on the high scores on the PAY.GAME. Yeah, that's pretty much it. And so if you're not familiar with Etherscan, you can also go to read contract, and you can actually execute all the methods that are like read methods that don't change any data, and it's free to execute. So this will show all the player addresses. The 3 high scores, so you need to enter, for example, 1, which I think is second place, and maybe 0 is first place. Yeah, so you see the score, which is in something called Y, which is like cents, but for Ether, but it's not cents, it's like a lot less than 100 of an Ether. Lifetime balance, so owner, that's me. So you can kind of see all this stuff. And then there's also write contract, and that allows you to directly write to the contract. So those are like, for example, the pay method. I think that's the only one that you can execute. I can execute these ones as well, but you can only execute the pay method. And you can enter how many ETH, like let's say 10 ETH, your name and your URL, and you can write it. And if you're connected to MetaMask, you can enter your score directly to the contract without using the website, which is kind of interesting. Yeah, so that's the game contract. Let's close this. And then there's also the price contract for the NFTs, which is a pretty standard contract. So if you're familiar with Solidity and with NFTs, you might have heard of the ERC 721 standard, I believe. I'm using a different standard, which is called ERC 1155, which allows you to have tokens that are fungible. So typically an NFT is non-fungible. So one NFT is always different from another NFT, and they can look similar, but they are not fungible. They're not interchangeable, which is the case for this NFT, and that NFT. But this coin, which you get if you participate, like anyone that enters the leaderboard gets one of those coin NFTs, those are fungible. Those are the same. Like the coin that I have is the same as you have. So those are not truly NFTs. And this one as well, like this kind of Hall of Fame NFT. There will be multiple of those, and they're all the same basically. They are interchangeable, so those are not strictly NFTs. And so the standard, the ERC 721 standard that most NFTs use, don't really allow for that kind of fungible token. But this ERC 1155 standard allows you to kind of mix and match between real NFTs and kind of more fungible NFTs, I guess. So that's why I use this contract. It's pretty standard. If you have any questions, I'm happy to answer them. I made a few modifications. For example, the mint function, which is a function to kind of create a NFT from nothing, like to create a token from nothing. It's set to only game, which means that only the game contract can execute this method. Even I, as the deployer, as the creator of the contract, cannot mint new NFTs. Only the game can, and the game will only will if there's like a new like a new high score in the list, as you just saw in the code. So that's kind of nice that anyone can see this code and they can see that it's fair. Is approved for. This is typically used for like marketplaces like OpenSea. You can give permission to OpenSea to kind of like transfer your NFT if it gets sold, for example. That's how OpenSea works. So you approve OpenSea once, and then they can kind of transfer your tokens for you. So that's something that the game contract should also be allowed to. It should also be allowed to move your NFTs around. At least the 3 NFTs for first place, second place, and third place. So that's what's happening here. I overrode the approved for all methods by checking, is the message sender the game? Then it's okay, and it's approved, or the regular is approved for all function. And then we have another method that we override called before token transfer. So this is executed anytime a token is about to be transferred, as the name implies. So we check if the message sender, so the person that tries to transfer the token, if it's not the game, then we're going to check, okay, which tokens are we actually trying to transfer? Because if it's one of those trophy tokens, we don't want to allow that. We don't want people to transfer away the first place prize or sell it on OpenSea, because it will get taken away again automatically if there's a new first place player. We'll try saying that a lot of times. So we checked for that, and if someone tries to transfer the one of those tokens and it's not the game that tries it, then we will basically prevent that from happening. Yeah, and that's the price contract. Yeah, and you can see it on OpenSea. It's opensea.io/collection/PAY.GAME. And you will see, for example, that this first place NFT is being moved around. First I got it because I was the first one to enter a score, because I kind of wanted to test out the website. So I got the first place initially. And then Micker, I think let's see here. He entered 0.05 ETH, so he became first place then. So he got the first place NFT then, and so on and so on. And right now it's owned by TJP. So congrats to him or her or they or it. Yeah, so this token kind of gets transferred around, which is kind of fun. And then we should see that a few people have this kind of Hall of Fame NFT. So I should have it. Yeah, Maker has it because he lost the first place. And AOX, which is domain.io. It's a cool product, by the way. Anyway, this video is running long. Let me know if you have any questions. I didn't go into the website codes. I'm happy to do that as well. It's not as nice because it's React and I'm not super familiar with it, so it's a little bit of a mess. But I'm happy to jump into that as well. yeah, let me know. Any questions, comments, and I'll see you on the leaderboard. Bye bye.